Today we are talking about absolute value expressions and equations. You know about absolute value. We're going to talk about it a little bit more today, and we're going to explore it more. And there are going to be things that I say that aren't going to be on the screen. And we're at day 5. Congratulations, we've made it through our first week of school. But at this point, you should know when all of a sudden Mr. Zukin's volume goes up and he gets kind of animated, like he's talking about something important. So maybe also write that down as a little side note somewhere, okay? You'll feel it when it happens. All right, absolute value and expression. Yes, we're also skipping 1.3. Yes, you are still responsible for 1.3. And I will give you a review sheet on 1.1 and 1.3 before we take our quiz next week. Okay? All right. So let's start with what absolute value is. What does it mean? Raise your hand if you think you know. What is it? That's what it does. And not quite. Mostly right. But what is it? What does it mean? Yes, sir.
The number's distance from 0.
On a number line. Very good. Okay. So the absolute value really represents, the meaning of the absolute value is how far away a number is from 0 on a number line. And Riley, to your point, it's not just always positive, it's non-negative. What's the distinction? Why do we say non-negative instead of positive? What's included in non-negative that positive does not include? 0. Very good. Okay. That's the only distinction. We talked about this the other day when we were talking about whole numbers. Positives and 0. That is the same as saying non-negative. You can be 0 units away from 0 in one specific case. There's only one case. But it's still included. Let me give a couple quick examples. Write down as much as you need to. This is just an illustration. It's not vital. Okay? Absolute value, you know this stuff already. The absolute value of negative 5 is 5. Because negative 5 is 5 units away from 0. The absolute value of 3 is 3. Because 3 is 3 units away from 0. Write as much or as little of that down as you need to. If you're totally cool with this, then don't write any of it down. But, and to Riley's point at the beginning, it either changes everything to a positive or it keeps it as a positive, because we're measuring distance. If you've ever used a tape measure or a ruler or a meter stick in your life, you've never measured something like, oh, negative 3 inches. Like, that's not a thing. I know sometimes in science we designate negatives for change in direction, but the actual distance itself is still the distance regardless of which direction you're measuring from. Okay? Now, this is one of those times where you're going to be like, you're going to move too fast. Well, I'm moving. Okay? For those of you who are just like, wait, I wasn't done. Remember, where can you go to find the rest of it if you really want it? The video. There's a video. Okay? So skip some space if you need to. It's not vital. You know that stuff already. You didn't make it to Algebra 2 Honors without knowing that stuff. Now, we are going to evaluate this algebraic expression. This algebraic expression I've just highlighted in red. We're going to figure out what that expression is equal to when x equals 4. No calculator required. Go. No, overall looks pretty good actually. I have a little bit of an issue with the way some of you did your work. And we're going to talk about that because one of the reasons that you do these problems and you work sideways, you go horizontal, is because at one point you were doing them on a piece of paper. And on that piece of paper you only had so much room. And you didn't want to have to use another page. Or you had a teacher that didn't teach you to do it correctly. But now you have an unlimited supply of paper at your disposal at all times without killing any extra trees. We should be doing problems like this, and we should be funneling down to the final answer. That's how I want to start seeing your work. Stop going sideways. Okay? If you did today, it's okay. Get out of that practice. Now, The other issue with this problem is, well, let's do the first step. The first step is we're going to substitute 4 in for x, okay? And we just have something like this, where the 4 goes in for x, and then we're going to just use order of operations and we'll get our answer. Now, back in the day you learned PEMDAS, and I hate PEMDAS for many reasons, but for the first reason that I hate it is the P. Okay? It's not always parentheses. Sometimes it's absolute value is a grouping symbol. It's telling you do what's inside there first. Sometimes it's a radical. Sometimes it's a fraction. Sometimes it's a division symbol. Sometimes it's a bracket. Sometimes it's a brace. Okay? There's lots of different quote-unquote parentheses. I wish they would call it GEMDAS with a G and stand for grouping symbols instead, because absolute value would absolutely be in there first. Now, one of the big mistakes that people tend to make is they see absolute value and they think, I got to turn everything positive really fast. No, please don't do that. That would be wrong. What we have to do is work on the inside here first. And I have a subtraction and I have a multiplication. So those of you who are going 6 minus 2 first, no, don't do that. Don't make up your own rules. Somebody spent a lot of time on this a long, long time ago. And we've all accepted that those are the rules. So the rules tell me to do multiplication first and leave everything else alone. Okay? So notice here that I have 2 times 4. That's 8. I changed nothing else. Okay? Now I have one step left inside the absolute value. 6 minus 8, what's that? -2. Okay? So here's where we're at. Now that I've done everything that I can possibly do inside the absolute value, how far away is -2 from 0? 2. Again, it turns it positive. So that is 2.7 plus 2, which is 4.7. Which many of you got. Raise your hand if that's what you got. Okay, hopefully you can see why, if you didn't, what you did wrong. Okay? And then, just for measure, give it a circle saying, I'm confident that's my answer. Or box it up, or highlight it, however you want to do it. Okay? But that's how we kind of use that working ourselves down and funnel to a final answer. Again, stop working horizontally. Stop working sideways. Work your way down one step at a time. The other thing I want you to notice here, notice there is no equal sign in anything that I've sort of surrounded in red. This is all called an expression. This is not an equation. In order for it to be an equation, there would have to be an equal sign in there. This is an expression. So this is an example of an algebraic expression that we simplified, that we evaluated. Okay, we didn't quote unquote solve. When we have an equation, then we solve for the variable. But here we evaluate it. Sometimes it'll be simplified when there's not numbers that you get a final numerical answer for. Okay, so that's that. All right. Questions so far? Next. Now we're going to solve some equations. Okay. Absolutely write this down. When solving absolute value equations, this is a must. It is capitalized, it is bold, it is underlined because I'm literally yelling this at you. It's very, very important. This has to be the first step. When you solve an absolute value equation, you have to get the absolute value part of the equation by itself on one side before you try to solve anything. If you don't do this, you will get half the problem wrong every single time. And my goal for you is to be a heavy hitter, right? I want you on the wall. And if you don't listen to me, you're not getting on that wall. Because I'm trying to give you hints to help you do as good as you can do. And score as high as you can score and learn as much as you can learn. Now, the next part that's important is whenever you're solving an absolute value equation, one of 3 things can happen. You can have 0 solutions. You can have 1 solution. Or you can have 2 solutions. And most of the time, you're not going to know at the beginning of the problem. It's going to be somewhere along the way where you can figure it out, and it depends where the variables are. Sometimes there are going to be more than one variable in the problem. When that happens, there's no way for you to tell how many solutions there are going to be until the end of the problem. If there's only one variable, then it's going to be a little easier to tell. But we do have 3 possibilities every time. Now I'm going to give you some really basic equations, and we're going to try to figure out how many solutions there are. All right? And they're going to be simple, really simple, really understandable. But they're good illustrations for how it's possible to have 0 solutions, how it's possible to have 1, or how it's possible to have 2. So let's start with this first equation. The absolute value of x equals 4. Now, I'm not going to talk about how to do it. I'm going to talk about what it means. Because I want you to have enough of that understanding. All right? What this equation is saying is there's some number that is 4 units away from 0. Or it could be some numbers that are 4 units away from 0. And I just want you to think about that for a second. Get those numbers, if there are more than one, or that number. Try to picture a number that is exactly 4 units away from 0. And then I want you to put your hand up with a number of fingers of how many of them there are. 0, 1, or 2. How many numbers are there 4 units away? Okay, lots of 2s. All right, what's one of them? What's one number that is 4 units away from 0? Just say it. 4. What's the other one? Negative 4, right? Both of those numbers are each 4 units away from 0. So here's the case where I could have 2 solutions. What's the case where there would only be one solution? What? 0. 0 is 0 units away from 0. I mean, that sounds ridiculous, right? But there's only one number. There's no negative 0. Okay, so that's the case where there's only going to be one solution. The only number that is 0 units away from 0 is 0. So now you're thinking, okay, I know what he's going to ask. How could I have no solutions? How could I have 0 solutions? What would the absolute value of x have to be equal to have no solutions? Go ahead, Preston.
It have like a negative sign in front of the absolute value.
Okay, that would be one way to think about it, or it could be on the other side. Like you can't be negative units away from 0. That's the way you have no solutions. Now, I just happen to pick negative 8 in this case. But if the absolute value is equal to a negative, that's impossible. It can't be. We're talking about distance. Distance can't be negative. You can't measure it with a meter stick and go, oh, it's negative 8 meters. That's not a thing. Okay? So if the absolute value is ever equal to a negative, once you've got the absolute value by yourself, then there are no solutions. And you are allowed to write the symbol for empty set instead of writing the words no solution. If you know set notation with the braces and you know how to write empty set that way, you can. I don't think any of you do. It's not very common. Now, let's go back to my original point. You could have 0 solutions, 1 solution, 2 solutions. Most of the time, you're not going to be able to tell at the beginning. A lot of the times, the absolute value is going to be equal to a variable. So there's no way to even look at it and know. So because of that, because there are 3 possibilities, something you're going to not like, but I'm going to require, is that you have to show your check for every absolute value equation that you ever do. Even if it doesn't say in the direction solve and check. Now today it's going to say solve and check. I'm telling you, here you go. Here's something you can write down. On your test, let's see, you guys are what, 4th period? So that'll be Thursday, September 5th. There will be a question where you have to solve an absolute value equation. It's just going to say solve. If you don't show your check, you don't get full credit, even though it didn't say it in the direction. I'm telling you that this is a standing thing. You have to show your checks all the time, every time we have an absolute value equation, whether it says it or not. I'm going to show you. I'm going to show you how to do a check. Basically, we're going to take our solution and plug it back into the original equation and see if it works. That's what a check is. So it's going to feel like you have twice as much work for a problem that you maybe shouldn't have. Okay? Got it? Ready for our example? Nobody's stopping me. I'm gonna go. Here we go. Oh, it was so dramatic and then it didn't. There we go. Here's the equation we're gonna solve. See, like I said, it says solve and check. So it's in the directions, and if you still don't check, then you're just not reading the directions. All right. My original equation is the absolute value of the quantity, 2x plus 7 plus 3 equals 40. There might be no solutions. There might be one solution. There might be two solutions. But the process that we're going to use to solve these equations will be the same every time. And then we'll find out how many of them we get. All right, so the very first thing that I told you when we started talking about absolute value equations was we have to do what first? Yeah, get the absolute value by itself. So I need this alone. What is preventing it from being alone? The 3. So what do I have to do with the 3? Subtract it from? And the 3, right? This is the additive inverse. That's what we talked about the property. Okay. This ends up giving me 0, making that go away on the left side. That's why we talk about the additive inverse. So what that gives me, what's 40 minus 3? 37. Okay. So here's where I'm at. Absolute value is alone. Now, here's where I'm going to say stuff that you should write down in your own words, however you need to make sure you don't mess it up from this point forward. Okay? Again, understanding the meaning of absolute value. We're saying that what's inside of here has to be 37 units away from 0. So 2x plus 7, whatever that is, has to be 37 units away from 0. So 2x plus 7 could equal what? No, just listen to the question. 2x plus 7 could equal what? Negative 37, because that's 37 units away. What else could it equal? Positive 37. Okay? 2x plus 7 could either equal 37 or negative 37. This is the part that will always be the case. The first equation is basically the exact same thing minus the absolute value signs, because all of this could be the positive. But all of this could also be the negative. Because if this was all negative 37 in here, this would be fine. If this was positive 37 in here, this would be fine. The mistake that kids make all the time, and please don't be that kid. Don't change anything inside of here. 2x plus 7, 2x plus 7. Notice those didn't change. The only thing that changed out of this whole original thing was that negative right there. Because what's inside, and that's why I talked about it at the beginning, what's inside of the absolute value has to be 37 units away from 0. Now, where these problems will get complicated is when this is a variable. Because we don't know if x is positive or negative. But the process that I'm showing will still be exactly the same. So go ahead and solve those two equations, and then I will show you how to do the checks. Go. So on this first one, my first move is to subtract 7. So 37 minus 7 is 30. Okay, then what? So x equals 15. All right, now I'm going to check this one first. before we move on to the second one. It's okay if you didn't. This is the part that's probably going to be a little new for you. All right, and again, write some of this stuff down. When you check, always use the original. Do not use any other equation. And this is true for any kind of check that you're going to have to do. Because later on in this course, there's other checks that you're going to have to do, and that is still true. Always use the original. Here's why. It is possible that you made a mistake somewhere along the way. And if you make a mistake somewhere along the way and you plug it into one of those equations that's actually now wrong because you made a mistake, you're going to get positive reinforcement on something that's wrong. And you're going to have confidence when you shouldn't. But if you plug it into the original and you made a mistake somewhere along the way, when you plug it into the original, that mistake is going to get revealed and you're going to be able to go back and go, okay, I gotta find it. So here's how we check. I basically only replace the x, or all the x's, there could be multiple x's, with that value. And here's what that looks like. So my original equation, notice I even changed the colors of where I plugged x in, and then I put this question mark above the equal sign. Basically what that's saying is, does this equal this? We're asking the question. We're not going to move from side to side. We're just going to simplify that left-hand side and see if it equals 40. If that left-hand side equals 40, then we know we did it right. Okay? Now, most of this I can do in my head, right? 2 times 15 is what?
30.
Plus 7. 37. So here I'm at. You're okay to skip that step. That's basic arithmetic. You're in Algebra 2 honors. You can do basic arithmetic in your head. Okay? What is the absolute value of 37? 37 plus 3? 40. So 40 does equal 40, which means we did it right. Check and a circle. Check that I did my check. Circle that answer works. And then we just have to do that same process on the right. Okay, now I know you already solved it. So my first move here is to do what?
Minus 7.
Minus 7. Okay? That gives me negative 44. Then? Yep. Divide by 2, which is? Negative 22. Okay? Now we got to see if that's right. And I plug it in the exact same way. So essentially it's going to just be this, but instead of a 15 here, it's going to be negative 22. I got my question mark. Does that all equal 40? Now I'm going to do a little more work here or show a little more work because there's a little more going on with the negatives. The other one's pretty straightforward. All right? So 2 times negative 22, what's that? Negative 44 right here. Okay. Negative 44 plus 7? Negative 37. Okay. Absolute value of negative 37 is positive 37. So we're good again. Positive 37 plus 3, that's 40. So yes, 40 does equal 40. Again, we're good. Check, circle. So everything down here is the check. And here's the check for the first one. Here's the check for the second one. Anytime you have an absolute value equation, you must do this. Okay? So we get to solve an equation and we get to evaluate an expression, the very first thing we did in one problem. Okay?